Good day, grade 12s. Welcome to Technical Mathematics. Today we are going to be discussing function with you. That's going to be the topic for today's lesson. But before we can start our lesson, I just want to advise all the grade 12, particularly for Technical Mathematics learners, please use the previous question paper to revise for this coming final exam. And you should also have the exam guideline for Technical Mathematics. You can get it from Google. Just type examination guideline for technical mathematics. It is there in DBE website. So just go through that document and check inside what do they say about the functions, and then also what are they say about other topics. All right. So let's start and see what are we going to be discussing for today's lesson. All right, under content we have functions, and then this topic, remember, it forms part of paper 1, and then it contributed 35 plus or minus 3 marks out of 150 marks. So it's a very important topic that needs to be revised thoroughly. And then under functions, we have linear functions. We also have quadratic functions, which is parabola. We have hyperbolic functions. We also have exponential functions. And then we have circle and semicircle. And then, of course, the last one is mixed algebraic functions. So today we'll be discussing all those type of functions that we have under technical mathematics or under functions. And then also be explaining the issue around the parameters. How does those parameters affect the graph? Because it's very, very important. That's where we should all start before we can go and answer the questions under functions. We need to clearly discuss how does it affect the graph. For instance, if we are talking about hyperbolic functions, the effect of A and Q, that's where we should first start before we can answer any question under hyperbolic function, so that we can be able to understand everything. All right, now let's see what are we going to have. As I was saying, that we'll be discussing the effect of parameters. Then we can all see that we are having a linear function in the form of y equals to mx plus c. We also have the parabola in terms of y equals to ax squared plus bx plus c. Or it can also be given in the form of y equals to a into x plus p all squared plus q. And then we then have y equals to a b to the power fx plus q. And then we then have to go to, which one is this? It's a exponential, not exponential, but hyperbolic function, which is y equals to a over x plus q. And then, of course, the last one is for circle, y equals to plus or minus square root of r squared plus I squared. So we are going to be having examples on those graphs, but first we are going to be starting with the original graph. That's where we should first start. Let us discuss the original graph before we can get the actual graph or the type of graph that you might get during your exam. But we need to first start with the original first. Now, let's start with the parabola graph, the original graph, the mother graph of parabola. That's where all of us, we started with the parabola. This is supposed to be arrows there. And then from there, this is the equation y equals to x squared. And then a learner should be able to determine the domain in the range first of the original graph. And then you must also be able to determine the x and y intercept, the minimum or the maximum values, and then turning point, equation of x of symmetry. Now let us first determine the domain and the range of this graph. Alright, the domain of the graph for parabola, it will always be x is the element of all real numbers. It does not matter whether the graph faces up or down or it has been shifted. But now for the domain, it will always be x is the element of all real numbers, or you can also write it in a form of x is the element of negative infinity to positive infinity. Then we then go to range. Range is y is the element of 0 to positive infinity. Now, for us to be able to determine the range, it depends on the turning point of the graph. And then on the turning point, we are looking for the y value, because remember when you are referring to range, we are talking about the y values. All right. Now we can see from this graph that the turning point is at this point where y equals to 0, and then it's going up there, which is going to positive infinity. Hence, we are saying the range is from 0 to positive infinity, and then you can see that 0 is also included because the graph is turning exactly at 0 there. So hence, we just used the square bracket. And then as for infinity sign, it will always carry the round bracket. It does not matter the infinity sign, it will always carry the round bracket. And then number 2, x and y intercept. X intercept is 0 and the y intercept is also 0 because it turns at this point. It touches the x-axis at 0, it touches the y-axis at 0. The maximum or the minimum. Now this one, it gives us what? The minimum, because they are saying if the graph of parabola is facing up, the value of y on the turning point, it gives us the minimum. If the graph is facing downwards, and the value of y on the turning point, it gives us the maximum. So in this case, it's very clear that it gives us minimum, which is 0. Then the turning point is 0 to 0. Then the equation of x of symmetry, x equals to 0, because what is that line? X of symmetry is this line which is cutting the graph into 2 equal parts, and this line is passing through the turning point. And then what is the value of x on that turning point? Is 0. Then it's x equals to 0. So that's how you should determine the equation of x of symmetry. Now let's have hyperbola graph, the original hyperbola. The learner should be able to do the domain and the range. Now let's first discuss the domain and the range. Alright, the domain of exponential, not exponential but hyperbola, is x is the element of all real numbers, but x should not be equals to 0. And then this domain, it will always be like that. It will never change. It will always be x is the element of all real numbers, but x should not be equals to 0, because now when you substitute 0 here, where you see x, then you're going to have undefined. So we don't want such. So hence we say x should not be equals to 0. And then as for range, you see y is the element of all real numbers, but y should not be equals to 0. Why? Because now we don't have one. We don't have you can see the what is this one? Asymptote is 0 there. It cuts this horizontal asymptote, cuts y at 0. Alright, and then now we say the range is y is the element of all real numbers, but y should not be equals to 0, because if you substitute 0 there, and then from there you have to cross multiply, then you can see that x is going to be multiplied by that x, then x is going to be disappearing. So we don't want. So hence we say y should not be equals to 0. X and y intercept, no x and y intercept. As you can see on this structure, you can see that these two curves, they are not touching these two lines, which is x intercept and y intercept. So these two x intercept and y intercept, they act as what? As the asymptote. Equation of asymptote, x equals to 0 and y equals to 0. And then equation of x of symmetry, y equals to y equals to x, which is this line. It's passing through this. This is y equals to x, the first one. And then the other one is y equals to negative x. So those are two axes of symmetry for a hyperbolic function. We then go to exponential. Now let us determine the domain and the range for this graph. And let's see. All right, the domain for exponential graph is x. X is the element of all real numbers. It will always be like that. It will never change. The same applies with the parabola one. The domain of parabola, it will never change. So it does not matter whether the graph is shifted where or is facing in any direction. But the domain, it will always be x is the element of all real numbers. And then we go to range, and they are saying range is y is the element. Range is y. Y is the element of 0 to positive infinity. Now, for you to be able to determine the range, depends on what? On the asymptote of the graph. All right. As you can see that the asymptote of this graph is where is y equals to 0, because remember this x-axis, it will act as what? As asymptote, and then you can see it cuts y-axis at 0, and then now when we have to determine the range, then we'll start with that 0. Then we'll say 0 is to positive infinity, because you can see the graph is moving up there, meaning it's going to the positive infinity. But it will never touch this line, which is x-axis. And then hence we use this round bracket at 0 there to show that 0 is not part, 0 is excluded, because the graph does not start exactly at 0. It's just approaching it. All right. So that is range. X and y, no x-intercept. As you can see, the grace graph does not cut or go through this or passing through x-axis. And then y-intercept is 1, because if you want y-intercept, you let x to be 0. And if you substitute 0 here, it's going to be 2 to the power 0, and it's going to give us 1. Equation of asymptote is y equals to 0, because this line, horizontal line, it cuts y-axis at 0. So that is for exponential function. Now let's talk about the circle. Then we're having a full circle, as you can see, because now it says y equals to plus or minus square root of 1 plus x squared. Right? Now, if it's a plus or minus, meaning we are going to be having a full circle. So if it was only positive, then we are going to have this semicircle that is above the x-axis. If it was negative, it's going to give us the semicircle which is below the x-axis, this one. Now let us determine the range and the domain of the graph. Is very simple. The range, the domain, you can see it's from -1 to +1. So that is x is the element of -1 is to 1. And then the range is from these 2 and this -2. So our range is y is the element of -2 to +2. Now determine the radius of the circle. As you can see, remember this one, where you see 1, it's supposed to be r squared. So our r squared in this case, let me just show you, r squared is equals to 1. Now we want radius, not r squared. So to get rid of this exponent 2, we have to put square root both sides. Then our r is equals to 1. So the mini radius is equals to 1 of this graph. Okay. So that's how you should determine the range. Now, these are important concepts that you should master in any function. And then first, let us understand the effect of the parameters such as y equals to bx plus q. And then I'm going to start explaining the issue around p, b, and q. Then you're saying if b is greater 1, then this is going to be the shape of the exponential curve. It's going to take this direction only if b is greater 1. And then they're saying if b is between 0 and 1, what is going to happen? 0 and 1. Then this is going to be the shape, it's going to be the direction of the exponential graph. So normally you will see in a form of fraction, it will be 1 over 2, 1 over 3, 1 over 4, 1 over 5. So that tells you that that number is between 0 and 1, and then that is going to be the direction of the exponential graph. And then the issue around q, so they are saying q, it determines the horizontal asymptote, and it also is a vertical, it's a horizontal shift, vertical shifting. It's either the graph is moving up or down. So that is the effect of this q. Remember, I repeat, the effect of q, it does give us what? It does give us the horizontal asymptote, and it's the vertical shifting of the graph. And then we go to hyperbola a. Let's explain a. They are saying if a is greater 1, greater 0. Let me just try. If a is greater 0, meaning it's positive, then the two curves, they are going to be on the first and the third quadrant. Then if a is less than 0, then the two curves, they're going to be on the second and the fourth quadrant. All right, so that is the effect of a. And then q is what? It's a vertical shifting. It's either this graph of a hyperbola is going up or down. All right, and again q, it gives us what? It gives us the horizontal asymptote, because the vertical asymptote, it will always cut axis at 0, but as for horizontal asymptote, it will depend with the value of q. Right, so q determines the horizontal asymptote. And then we go to parabola. Now if parabola is given in this form, they are saying a, let me talk about a. If a is positive, which is greater 0, then the graph is going to face up for parabola. And then if a is less than 0, meaning the value of a is negative, the graph of parabola is going to face downwards. So that is the effect of a. And then we go to p and q. They are saying p, it gives us the value of x on the turning point, and then q, it also gives us the value of y on the turning point. Meaning if it is in this form, there is no need for you to calculate the turning point, you just take it. But now this one of p, every time when you take it from the equation to the point, it will always change the sign. If it's negative p, it's going to be positive p here. If it was positive there, it's going to be negative here. Hence, I use the negative p. But as for q, you take it as it is with the sign. All right. So that is the effect of p and q. And again, p is horizontal shifting, while q is the vertical shifting. But the most important, you must know that this determines the point and the turning point of the graph. And then the concept to master in function 1, you must be able to sketch the function. And then be able to sketch the function, you must find the x and y intercept, the turning point and the asymptotes, and then find the equation of a function if the sketch is given. Understand the concept of asymptotes and axis of symmetry, and you go to the domain and the range. You must be able to determine the domain and range of all these functions that we have explained, and then you must also interpret the graphs. That is the most important. You must be able to master such. All right, now let's have this question and see. The diagram below shows the graph of f of x equals to negative into x minus 3 all squared plus 25, and g of x equals to 2 into 1 over 2 to the power x plus 1 negative 4. The graph f has the x-axis at A and C and the y-axis at E, and has a turning point of D. The graph G has the x-axis at A and the y-axis at B. Write down the equation of asymptote of G. Now let us determine the asymptote. Asymptote is y equals to negative 4, because I did explain the issue around this function exponential, that the q is stand for q. We said q, it does give us what? The horizontal asymptote. So the horizontal asymptote is negative 4, and then write down the coordinate of turning point. The turning point is what is going to be positive 3 is to 25. I also did explain this one, that if it isn't given in this form, there's no need for you to calculate the turning point. You just have to take these two values, which is 3 and 25. So that the turning point is 3 is to 25. And then we then have to determine the what? Write down the range of f. So we are in need of the range of this graph of parabola. Then the range is y is the element of negative infinity to 25. Then remember, earlier on I did explain, if you are in need of the range for parabola graph, it depends on the turning point. And on the turning point, the value of y. So what is the value of y on the turning point is 25. So that's where the graph starts, and then it goes to negative infinity. But because you only have to start with a small number to a big number, negative infinity is smaller than 25. Hence, we have started with negative infinity is to 25. And then this one of 25, it will always carry what? A round bracket, because the graph is turning exactly at positive 25. Calculate the length of EB. Calculate the length of EB. Now let's determine the length of EB. Then first we need to determine the coordinates of E. So you can all see that E is the y-intercept, and then x is 0 there. So if we put 0 on the equation and then determine the y-intercept, then the y-intercept is going to give us 16. And then we then go to the coordinates of B. The coordinates of B is going to be 0 is to negative 3. So how do we determine that? You just go to the graph of exponential, where you see x, you just substitute 0 there. Then when you simplify it, it's going to give us y-intercept negative 3. So the coordinates are this. And then now, if we can just get the distance of EB, it's going to be 19 units. Determine the value of x for which the graph f decreases. That value is x is greater 3. Then now, remember when you have, let me just draw this asymptote, symmetry of symmetry. Now the graph, they're saying from this, in this terminal arm, the graph is increasing, and then just after this turning point, the graph starts decreasing. So we want where the graph decreases. And then what is the value of x from here to this side? The value of x from this turning point is positive 3. So now the graph starts decreasing from positive 3 going to the right. All right, so we know those numbers, they are greater than positive 3. Hence we say x is greater 3. All right, that's where the graph is decreasing. If P of x equals to f of x plus 2, write down the coordinates of the turning point of P. First, to write this one, we know the equation of f of x is negative into x minus 3 all squared plus 25. And then we then say plus 2, then you then have this one. So the equation of P of x equals to negative into x minus 3 all squared plus 27. Our new turning point is going to be 3:27. So that's how you should determine the turning point. The diagram below shows the graph of f of x equals to negative x squared minus x plus 6, and then g of x equals to mx plus c. A is negative 2:4. C is the point of intersection of the graph. Let's determine or answer the following question. Determine the x-intercept of f. Let's determine the x-intercept. If you are in need of x-intercept, you just let y equals to 0, and then 0 equals to negative x squared minus x plus 6. And then first, before you factorize the quadratic, you have to make sure that the coefficient of x squared is positive. Now to make it positive, we are going to divide each term with -1. Then we are then having 0 equals to x squared plus x minus 6. You then factorize, which is x plus 3, x minus 3, and then from there you solve the value of x, which is x equals to -3 or x equals to +2. So those are x-intercept of the graph of f. Write down the equation of the axis of symmetry of f, and then you then use this formula, x equals to -b over 2a. This formula is going to help you to get what? The value of x on the turning point, and also it gives us what? The equation of x of symmetry. Now that equation is x equals to -1/2. So we have answered that question. We have determined the equation of axis of symmetry. All right. So x of symmetry normally is what? Is the value of x on the turning point. And then determine the range of f. For us to determine the range, we need to have the value of the value of y on the turning point. Since we don't have the value of y on the turning point, we first have to determine that, and then we are going to take this x value of the turning point and substitute the originally given equation. As you can see, where you see x, you just substitute with -1/2. Then you just press your calculator and it gives us the value of y of the turning point as 25/4. Now we can be able to determine the range. Our range is y is the element of -infinity to 25/4. And then write down the value of x for which f of x is greater 0. Now this one of greater 0. Remember, this graph of f is the parabola graph, and they are saying the graph below the x-axis is negative. The graph below is negative. And then the graph above what? X-axis is becoming positive. This is positive, this is positive, this is positive. Now, for f of x to be greater 0, it must be positive. Meaning we are only going to be focusing where the graph is positive. Meaning it's from this point, this x-intercept, and then going in this direction, and then it's from this x-intercept going in this direction, because you can see from here up to the turning point until you reach this point, that graph is positive. So it's from between those two x-intercept, because once you go out, you can see that the graph becomes negative. If you go out, the graph becomes negative, and we don't want where the graph is negative. We want where the graph is positive, because positive is the one that is greater 0. So now, if that is the case, you can see these two arrows, they're going to face each other. Then we're going to put x in between, and then it's going to be x is greater -3 and x is less than 2. So that's how you should answer that question. A sketch below are a graph of f of x equals to ax squared plus bx plus c and g of x equals to k mx m to power of x. The parabola has intercepts -5 is to 0, -1 is to 0, and 0 is to 2. The exponential graph passes through the point 0 is to 2 and then 1 is to 6. Now let's determine the following questions. Determine the equation of parabola in the form of this. In the form of that, let me just remove this. In the form of this one. Y equals to ax squared plus bx plus c. Now, how do we determine the equation? So, in a parabola graph, if you are given a 2x intercept and any point on the curve, then we are going to use this formula to determine the equation of that equation of that graph, which is y equals to a into x minus x1 into x minus x2. So x1 and x2 they stand for the x-intercept. All right. Now we first have to substitute the x-intercept. So that is the negative of the formula multiplied by negative of this -5. Hence we have a positive there and positive there. Now thereafter we then have to look for any point except the x-intercept on the curve so that we can be able to determine the value of a. That point is 0 is to 2. You can see this point is there. Then we substitute this point. Then we simplify it. Then you solve the value of a. So a value of a in this case is 2/5. Then now you substitute. From there you're going to open the bracket and then you multiply with that 2/5 outside. Then this is the equation of the parabola graph. That is the equation. The second question, determine the value of m and k. I think we're going to be able to determine that on the next lesson, on the next slides. I mean, let us go and see. All right, determine the value of m and k. Let's find the m and k. First, we are going to be substituting with what? Because we're on that curve of exponential, we're having 2 points, which is 1 is to 6, and then the other one is 0 is to 2. Then now, when you are using those 2 points, you need to be very, very careful. Now, you can see that we cannot be able to use this one of 1 is to 6, because if you substitute 6 here and then 1 there, we're still going to have 2 unknown, which is k and m. But now, when you use this one of 0 to 2, look at what's going to happen. Y is 2 and then x is 0 there. And then we all know that m to power 0 is going to give us 1. So we're only going to be left with k. Then you're going to be able to get the value of k, which is equals to 2. So the value of k equals to 2 in this case. Then after we have used that point of 0 to 2, we are no longer going to use it again. But now we're going to be using that one of 1 is to 6 to determine the value of m. All right. Y is 6, and then we have determined the value of k, which is 2, and then x is 1. Then from there, you can divide both sides with 2, then it's going to give us the value of m is equals to 3. Write down the equation of asymptote of the exponential curve. That is y equals to 0. You can see this point or this line which is passing through y-axis at 0. So that x-axis is going to act as what? As asymptote. Determine the curve of x, which these two graphs, f of x multiplied by g of x is less than 0. That is the answer, but let me just explain on how do we determine this question. If they are saying determine the values of x for which f of x multiplied by g of x is less than 0, meaning after multiplying the two graphs, you must get negative value, because a negative value is the one which is less than 0, meaning it's either this one is negative multiplied by positive, or this one is positive multiplied by negative. So when you say negative multiplied by positive, it gives us negative. Positive multiplied by negative, it gives us negative. Alright? So that's where we, meaning the other graph should be negative, the other graph should be positive. Alright? In order for these two graphs, when you multiply them together, they give us where is less than 0. Alright? Now, the graph of f, remember, is negative here below the x-axis. That's where the graph is negative below the x-axis. The graph starts to do. And then now, any graph above the x-axis is positive. So this graph is positive, this graph is positive, this one is positive, this one is positive there. Now, it's very clear from this structure here, because we want where the other graph is positive, the other graph is negative. Is through this point. If you can just draw a line like this, then if you can draw a line like this one. Now, you can see from this portion here, the graph, the other graph is negative and the other one is positive. That's where we need a solution. That's where we're going to have our solution. All right. So it's from which side? It's from, it's between negative 5 and negative 1. So we get inside because it's between the two numbers. We cannot go outside, well, because once you go outside, they are both positive. If you go this side, they are both positive. So it's only between negative 5 and negative 1 where the other graph is negative and the other one is positive. That's where we want the solution. And then if that is the case, the two arrows, they are facing each other, then x is going to be between. Then you say x is greater than negative 5 and x is less than negative 1. Because if we move from negative 5 and then we take this direction, all those numbers, they are greater negative 5. Hence we see x stand for those numbers which are greater than negative 5. All right. So that's how you should determine this question. The sketch below is the graph of f of s equals to 2 times b to the power x plus 1 plus g. The graph of f passes through the point 1 is to 20, and then b negative 1 is to y. The line y equals to 2 is the asymptote of the graph. Show that the equation of the graph is given this one. Let me show. First, we have the standard equation that is given, and then we know that g is what? Is the horizontal asymptote. It is given, which is 2. Hence, you see I've just substituted with 2 there. Thereafter, I'm looking for any point on the curve for us to be able to determine the value of b. And then the only point which is available is point A, because point B does not have the value of 1. So I've taken this one, and then y is 20 there, and then x is 1. Then I substitute 20, and then where I see x, I substitute 1. Then from there, I'll transpose this positive 2 to that side. Hence, we see negative 20, negative 2. Then 1 plus 1 is 2. Then after determining this, we are going to be dividing with what? With 2. And then we are going to be left with b squared equals to 9. And now that 9 can be written as 3 to the power of 2. Then if we have the same exponents, then we can just say therefore b equals to 3. And then that the equation is this one. So we have shown that the equation of f of s equals to 2 into 3. to the power of x plus 1 plus 2. So that we have determined. Now calculate the y value of the point B, meaning we need to take this value there, we substitute to the equation, and then y is y, and then x is -1. Then from there, this is what we are having, and then 3 to the power 0 is 1, 1 times 2 is 2, 2 plus 2 is 2, is 4. So the value of y on that point is positive 4. Write down the range of f. Remember, we said the range depends on the asymptote, and then our range is y is the element of 2 is to positive infinity. The asymptote you can see is 2, and then now the graph is going up there. You can see the point is going up there, so it's going to positive infinity. Hence, the range is 2 is to positive infinity. Or it can also be written in this form: y is greater than 2. It's either in this form or this one. Write down the domain and the range of this graph of parabola. Now, I said clearly earlier on that the domain for parabola, it will never change. It will always be x is the element of all real numbers. The range it will depend on the turning point, and then on the turning point we are looking for the y value, and the y value of the turning point is -18. Hence, you see that it's the range is y is the element of -18 to positive infinity, because a is positive, meaning this graph is facing up, so it's going to the positive infinity. But what is the turning point with the value of y? It's -18, so it's -18 to positive infinity. Write down the turning points. The turning points is 4 is to -18, and then write down the equation of x of symmetry. If you are in need of x of symmetry, you just take what is inside this bracket, which is x minus 4 equated to 0. You then solve for x, and then the equation of x of symmetry is x equals to -4. All right, now we are having a question under circle. Let's study this question. In the diagram below, a semicircle is defined by this equation. There's a semicircle. Remember, it does not have plus or minus. It's only having negative. And I also did explain, if it's negative, you are having a semicircle that is below the x-axis. And you can see we're having that. And the tangent of a circle at point P, -3 is -3. Determine the equation. Determine the equation of a semicircle. Let's determine the equation of a semicircle. This is the equation. Then from there you substitute the point from the circumference, which is -3y, and then x is -3. Then from there you divide with negative. You put square root inside, and then you transpose 9. That side is 18 square root, and therefore the equation is h of x equals to negative square root of 18 negative x squared. Right? So that is the equation. For us to determine the equation of a semicircle, we just need to get the value of r squared. So in this case, the value of r squared is equals to 18. Then you have done determining the equation of a semicircle. The equation of a tangent to a semicircle at P, we need to determine the gradient first. But now we are going to be determining the gradient of this OP, which is the gradient of radius first. Because now we do have the coordinates of O, we do have coordinates of P. All right, because we all know that this radius is always perpendicular to the tangent. Then this is what we need, and then OP. We then determine the coordinate of OP. From there, you divide it. Then it gives us the gradient of the tangent as -1. So we were only needing the gradient of this line of the tangent, and then also the point is there, which is P, -3 is -3. Then after, since we have determined the gradient of a tangent and the point we have, then we can now start writing the standard equation of the straight line. You then, from substituting, then you open your bracket with -1. It's going to give us negative x, negative 3. And then this positive 3, remember when you take it, this side is going to be negative 3. So negative 3, negative 3 is give us negative 6. So that is the equation of that tangent. A circle whose center is at the origin passing through the point negative 2 is to 4. Determine the equation of a tangent of the circle to the tangent at the point negative 2 is to 4. And then we're in need of this, the equation of this line, which is the tangent. Now, first, we need to determine the gradient of the radius, because we are having point O, which is 0 to 0, and then this one is negative 2 is to 4. Now, the gradient of the radius is negative 2, all right? But because they are perpendicular to each other, then it's going to be the gradient of the radius multiplied by the gradient of the tangent equals to negative 1. Then we have determined the gradient of radius, which is negative 2. So we are in need of the gradient of the tangent. We can now divide both sides with negative 2. Then it's going to give us positive 1 over 2. So we are now having the gradient of a tangent. We are having a point. Now we can be able to determine the equation of that tangent. We start writing the standard equation. We then substitute the values. And then from there, you open your bracket with that half, which is 1 over 2. 1 over 2 multiplied by x is 1 over 2x. And then 1 over 2 multiplied by 2 is 1. And then you take this negative 4, you transpose to the right hand side, it's going to give us positive 4. Then you add them together. Then it gives us our equation of the tangent as y equals to 1 over x, 1 over 2x plus 5. All right, thank you very much for being with me in this very interesting lesson. I hope everything that we have discussed is going to help you in preparing for this coming exam. And please, let me just remind you once again, please use previous question paper when you are revising, and then you should also have the examination guideline for technical mathematics. So let me just leave you with this great ways that says, our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. Thank you very much. Have a nice evening. We'll see each other on the next lesson. Bye.